the graph of a function to compute the limit. So here we're given the graph of our function f of x, and our goal is for different x values we want to compute the left and right side limit. So let's consider the x value, x is equal to 1. And our goal is to compute the limit as x approaches 1. So we'll compute the limit as it approaches 1 from the left of our function, and we'll compute the limit as x approaches 1 from the right of our function. Now, as we approach x equals 1 from the left, we're going to find x equals 1 on our x-axis, and we'll look at values that are less than 1. So if I'm approaching from the left, I'm looking at values that are less than 1, and I want to see what are my corresponding y values. So for the graph, as I'm approaching 1 from the left, the y values are getting closer and closer to y is equal to 3. As I approach 1 from the right, I'm looking at what does my graph do. It's getting closer and closer to y values equal to 3. And because the left and the right hand limit are the same number, we're able to say that the limit as x approaches 1 of the function f of x is equal to 3. Okay, now we're going to do another example. So that was for x is equal to 1. Let's see what happens as x approaches 3. So we want to find the limit as I approach 3. So I'm going to compute the limit as x approaches 3 from the left of my function, and then I'm going to write the limit as x approaches 3 from the right. Okay, if I'm approaching 3 from the left, that means I'm looking at values less than 3. So for values less than 3, my graph is going down to negative infinity. So here we would say that the limit is equal to negative infinity. That is because as I approach 3 from the left, my graph just goes down to negative infinity. As I approach 3 from the right, I see my graph is getting closer and closer to the y value 4. So we have that the limit as it approaches 3 from the right is equal to 4. And because this limit as I approach 3 from the left is not an actual value, we say that the limit as x approaches 3 of the function does not exist. So remember, for the limit to exist, we need it to actually equal a concrete number, and we need the left and the right hand limits to equal that same value. All right, let's do our next example for x is equal to 5. So the limit as x approaches 5, we want to compute your limit from the left, and we want to compute the limit from the right. As we approach 5 from the left, so here's 5 on our number line. As I approach it from the left, my y values are getting closer to 2. As I approach it from the right, though, so for values larger than 5, my y values are getting close to negative 3. Okay? Now, these both do equal a number, but in this example, we would say that the limit as x approaches 5 does not exist, and that's because the limit from the left-hand side does not equal the limit from the right-hand side. So the limit as x approaches 5 of the function does not exist. Okay? Now, the last example we're going to get is we're going to compute the limit as I approach 6. So again, you'll compute your limit from the left, and you want to compute the limit from the right. Now, as we approach 6 from the left, our graph appears to be going off to positive infinity. So we'll say that that limit is equal to positive infinity. And as we approach 6 from the right, it's also going off to positive infinity. Okay? Now, although infinity quote unquote equals infinity, that is not what we would say here. Again, we would say that the limit as x approaches 6 of f of x does not exist, because for the limit to exist, we need it to equal a concrete number, not infinity. So infinity is just a concept. Remember, it's not actually a concrete number. And for your limit to exist, we need that the limit has to equal a concrete number. Okay, so that completes the example.